Hello, hello. Welcome to today's webinar. I'm really excited that you're here today. We have a fantastic group, and I imagine that you'll have a lot of questions here. So just to get the logistics out of the way, we're going to try to blaze through this webinar content. Your time is very valuable. We'll try to see how close to 30 minutes we can get for delivering this content. But my commitment to you is that I will not conclude the webinar until every one of your questions is answered. I'm actually pretty good at weaving in the answers to those questions in line during the content. So don't be shy about asking the questions while the content is going on, and I'll find an opportunity for answering it in line. But if there's any questions at the end, I'll stick around. And you'll also have my email address. I love receiving emails with questions, and you can find me on Twitter as well. So let's jump right into it. Today's webinar is the 7 must-haves for a comprehensive DevOps environment. And my name is Jeffrey Palermo. I'm the chief architect for ClearMeasure, and we love empowering software development, enabling you to deliver world-class results. And so we're going to dive into what makes up a comprehensive DevOps environment, what capabilities need to be there from an architecture perspective, and the 7 must-haves that you absolutely have to have. So the agenda of the webinar is organized like this. We'll talk through the objectives and what we're really going for, and then we'll talk a little bit about just the architecture that goes into a DevOps environment and some of the things that are absolutely needed, then go point by point into these 7 must-haves, and then suggest some next steps for you. So that's how it's organized, okay? And also during the webinar, in the chat window, my assistant will be delivering some resources in some links, and you can certainly open up the chat window there. Now, I want to give you something of value and help you get this DevOps environment put together if you don't already have it. At ClearMeasure, we have a .NET DevOps framework that kind of takes the huge bit of complexity in the world, in the software world, of putting all these things together and simplifies it down. So I don't want you to continue perhaps to be frustrated and sometimes trapped by the software that you work on that seems to always find a way to break when you're building, deploying, when you're trying to put together this DevOps environment. And also, we understand sometimes in the software world, you can lose weekends and you have surprise overtime due to software builds and deployments going poorly. So, at ClearMeasure, we've helped countless professionals around the world with our .NET DevOps framework. And my latest book, .NET DevOps for Azure, it exposes the secret about how any team can have a fully automated DevOps pipeline by just following a concrete 7-stage design. So here's what you need to do on this front. Number 1, read my book, and I'll give you a select excerpt from the book for free, select chapters, just for being here today on the webinar. So send me an email and I'll get it to you. And whether you're watching live or if a coworker shared this recording to you, I'd be happy to get that to you. Number 2, you want to read that and understand the 7 stages of a DevOps pipeline. That's in the book. And then number 3, launch your own .NET DevOps pipeline. And you can use our public project as a model, and you'll find that in the book. And if you do this, you will have a complete and fully automated DevOps pipeline using Azure, and that'll enable you to move faster and with higher quality. Also, next week, actually, next Thursday and Friday, I will be the lead instructor for another installation of our .NET DevOps Bootcamp. There are still a couple of seats available that we could squeeze in if you want to get in for next week's class. And so get in touch about that, or you can use the link there on the screen. All right. Another resource that you'll be interested in is the Azure DevOps podcast. This is for people who are shipping software using the Microsoft platform, and the whole process and environment architecture that goes into that world. And a little bit more information about the .NET DevOps Bootcamp. The URL is there. It's next Thursday and Friday. Now, let's look at the objective. Now, just from looking at the attendee list of this webinar, you all are software leaders, and with the right strategy, things fall into place nicely. With the wrong strategy, there's really no level of execution that can make it great. And architecture in the software world is really a special type of strategy. And there's three types. One is the design of the system or the software, and then next is the design of the organization that builds the system. And then third is the schedule and meeting schedule and budget targets. So DevOps helps give us a model to ensure that we identify all of the needed architectural elements. And if you've ever read the Phoenix Project or the DevOps Handbook, there's three principal areas of DevOps. The first is flow, the second is feedback, and then the third is continuous learning. And so all three need to be present in your environment. So let's talk a little bit about just the bounds of what needs to be in a DevOps environment. It can be easy to think of architecture as just the structure of that application, and it is, but this DevOps environment that we're putting together for our team, that is a system in and of itself. And so as the leader that you are, design this system, not just the .NET application. So, we can think of the inputs and the outputs of the DevOps environment as the system. On the one hand, coming in is a feature request or a request for a change or some analysis of what's going on in production. And as output, we are making changes to features and or whatever request for any change. And we're also putting out capabilities to better observe the software system. Now, in the Microsoft world, a lot of people ask, what does the DevOps environment look like? Now, this is a highly shrunken technical blueprint for the structure and flow of a pipeline implemented with Azure DevOps services and Octopus Deploy. It has continuous integration build and a 3-tier deployment pipeline. And I want each of you to have this. So my assistant is posting a download link in the chat. And if you miss it, just send me an email. This is the top third of our DevOps architectural poster illustrating ClearMeasure's .NET DevOps framework. And you can print it out at your local print shop. It's best printed 2 feet by 3 feet. So it's pretty big. And this is the overall architecture for an automated DevOps pipeline. And it shows where the 7 key stages fit in. And we'll go through each of them. And I'm going to talk about how each of them have to be done right in order to have success in this area. And there's so many tools that go into a DevOps environment. I'm not going to get too heavily into tools today because there's so many of them out there. Azure Pipelines tends to be the great orchestrator for deploying sophisticated applications. Octopus Deploy tends to be the cream of the crop there. For sophisticated database solutions, Redgate SQL Change Automation tends to be the cream of the crop there. I mean, there's so many tools that go into it. I just don't have time in this webinar to go into tools. I'm going to stick with architecture and process in the 7 must-haves from a characteristic perspective. Now, the entire poster kind of looks like this. I know it's way too small. You can't see it, but that's what you'll get whenever you click on the link that's in the chat and get it to you. Okay. All right. So before we dive into the 7 must-haves, I want to cover real quickly 3 scenarios that your DevOps environment needs to support. And the first scenario is the developer scenario and what the developer does. The next is the team scenario. The next is the support scenario when it's in production. And so the developers are constantly thinking about getting it working. I need to write the code. I need to implement a feature. I need to get it working. And so in order to verify that I've gotten something new working, and at the same time I haven't broken other things, We need to build and test, and we actually need to deploy to some environment to really know that I haven't broken something. And so that's one scenario, and a set of tasks and activities to answer those questions. The team scenario is delivering a good next release candidate. We want to continuously integrate the changes from multiple members of the team, and we want to put it all together for a good release candidate next. And then the support scenario in production is that there's people using the software to get their job done, and we want a really fast cycle for any kind of adjustments or bug fixes. And so what's really important to layer on in order to support the people that are using our software is runtime observability, so that we know what the software is doing, what the people who are using our software are doing. So those are the three scenarios that we think about when putting together a DevOps environment. But now we'll break this up into cycle time. So Onion DevOps is a pattern that I talk about in my book. And when you really think about it, you can draw concentric circles, kind of like an onion, and they represent the various cycle times that any software organization is going to have. And an individual developer writing code, that's the inner cycle, and that's going to spin, we hope, really, really fast and have many, many cycles throughout the day. That I make a change, I see it working on my box, I commit some code to my feature branch, I make a change again, run it, code, change, run, change, run, change, run, commit, and that's the inner code loop. And we want no friction there because we want developers to be able to move really fast. The next cycle is the team cycle, made up of multiple developers, and that is when I submit my feature branch using a pull request for inclusion in the team's master branch. And this is where the bulk of continuous integration comes in, where we are continuously integrating changes from multiple team members, and we want to have a really short cycle time there as well, delivering a new release candidate to whatever our product team is at our company, whether we have dedicated testers, a product owner, whatever person or group of people represent the strategy for what product we're trying to get out to our customers, whether they're external or internal employees of our own company. So you can see how the cycle times are nested. And then of course the customer cycle time is people using it in production, and then how quickly we can take a problem report or a bug report and get it fixed and get it back out to our customer, back out to our user. And the inner cycles spin many, many times for each of the other cycles. And so just remember that concept as you analyze your process and what steps go into each of the cycles. All right, so the 7 must-haves are right here on the screen. Pre-code design, before any code is written, then the source control structure, the flow of the private build, the continuous integration process for the team, a testing and verification capability, production release capability, and telemetry observation. Those are the 7 must-have capabilities of a DevOps environment. I'm just going to breeze through each one of them. So let's talk about pre-code design process. This is the overall flow of the overall pipeline. And you can see in the second row, we have the developer. The developer's writing some code, the developer's making some change. But there's 4 steps before a developer can write any code or put hands on keyboard. And we have to make these 4 different design decisions before a developer can write any code. Conceptual definition is what the heck this is the good old requirements of what are we trying to accomplish. Then user experience design is figuring out how we want a person to experience the change. Even headless features that just integrate our application with something else and move data from one system to another, the user experience design may be figuring out if the data needs to get over there within 5 seconds, 5 minutes, or 5 hours. And because that goes into what the user's experience is, how a person is going to experience this software behavior once it's in place. Those decisions need to be made. Then technical design, architectural patterns, design patterns. Do we need any new libraries or NuGet packages. All those decisions need to be made. If we're modifying the data model, things like that. And then acceptance criteria or test design. We need to know what it means to be done. And the best acceptance criteria is an executable test scenario where we have a bullet list of what actions to take to verify that this behavior is right. Now, it's important to model your process in a Kanban sort of way with stages. And so your Kanban board likely is going to look like this. The middle column is the development column. And notice that it's rather symmetrical. There's 4 pre-development design decisions, and then there are essentially 4 validation stages after development. If you're using the not started, in progress, done type process, there's no way that that is going to give you enough visibility to determine bottlenecks. So you really need to model out the different design decisions to get ready to define what development is to be done, and then the stages of validating different areas as it goes on to production. So at a minimum, we see high performing teams have a minimum of 9 stages, and these are candidate names for those 9 stages. Okay, and next is just a blow up on the pre-code design process, because that's really what we want to be put in place, those 4 different design decisions. All right, so that's the first one. Next is the version control structure or source control. And we want to make sure that this is structured properly, because the source control repository is the headwaters of a DevOps pipeline. To use the water metaphor, if the pipeline is a smooth, steady flow of software changes out to our customers, and every step of the way we have quality control filters that trap impurities so that none of the bad stuff gets to our customers, then the source control repository is the headwaters that provides the water. It's the beginning. And so we have to have this structured properly, or nothing else in the DevOps pipeline goes well. And so it's important that we have one application, one buildable, one deployable application unit in the version control repository, not more than one. Now, if you have a web application and an offline job and a SQL database, those might all be deployable components of a single application, and that's fine. That's perfectly fine. But you don't want 2 completely separate applications residing in a single Git repository, because then the rest of your pipeline is trying to somehow figure out how to separate it out, because it deploys on separate cadences, and it really is just 2 different things. So that is a must-have. You have to have one application per Git repository. And also be cautious not to unnecessarily split up application components into different Git repositories. Okay. All right, next is the private build process. So the private build, the goal of the private build, by the way, is part of continuous integration. And the 2007 Addison Wesley book on continuous integration calls out the 2 types of builds. The one build is the private build, and the next is the integration build. So for the private build, this largely in a modern source control world happens on feature branches and is inside the developer's development cycle, the code cycle. We change some code, we run the private build script locally on our development workstation. Then we commit and push to the Git repository on our feature branch. Then the integration build can carry on. But the private build sets up our local development workstation. If there's any environment variables that need to be done, it does a compilation, runs the unit tests, runs the component level integration tests. Make sure that we quickly get a sanity check if what we just changed broke something big. It also creates the SQL Server database schema locally and changes, runs any migration scripts so that we can validate that our data access works properly. In general, the flow, if I have a new developer starting on my team, they should be able to clone the Git repository, run the private build, and be up and running the application, making a change. we shouldn't have to have a document about configuring the environment so that the application works. All of that should be baked into the private build script. All right, the next stage is the integration build. And the flow of that is kind of like a test on the test-driven development front. If you've ever studied test-driven development, you've heard of arrange, act, assert, which is kind of the 3 types of activities for any test. Arrange is get set up, provision the environment, be ready to do the action. Act is actually to invoke something about the software, and then assert is make sure everything went well. So the integration build needs to clean up previous artifacts, needs to stamp the version number, needs to finish setting up the environment, and in most cases, migrating the database is a key component of creating the build environment because it's a key dependency. Then the act is actually compiling, going from test or text source code to executable source code, intermediate language in a DLL form. And then the assert is the tests, the unit tests, integration tests. Some mature teams move the static analysis over to the assert column, and it will actually fail the build upon a static analysis warning. For others, it's just informational in nature. And to close out, we need to package up the release candidate and then publish it. That's the structure of the integration build. You need to have the integration build, and you need to have it running on every feature branch as well as master. Don't just wait for a pull request in order to run the integration build. And the integration build and full system testing fit together on feature branches and master because we want to essentially enable a pull request process that includes the running of all of the tests that we have, including the automated acceptance tests. Automated acceptance tests tend to have to run on a fully deployed environment. And so after doing an integration build, we often need to do an automatic deployment so that we can run our automated acceptance tests so that we know that we didn't break anything. And then we can create a pull request because then we have confidence in what we did on our feature branch. And then a pull request can be inspected using the standard inspection checklist that our team has agreed upon. All right, the next is the capability to do a production release. And it's important that we don't do anything new in production, that the only things that we do in a production deployment are the things that we have done in multiple environments previously. And so you see in the TDD environment, which stands for test-driven development, we do a lot of things. And then we do less in the UAT environment, we do less in the production environment. Now, every deployment pipeline needs a minimum of 3 environments because there are 3 distinct types of environments. And so you need 1 of each environment type. The TDD is for full system acceptance tests. It is the test-only environment. There's no reason for any humans to be using that environment. We provision it on demand, we test it automatically, and then destroy it. And then UAT, user acceptance test, that's an example of the second type of environment, which is a manual test environment. And then everybody knows production. We need at least 1 of each environment type, but you can have as many as you like to. But we need the capability to automatically deploy to production and automatically deploy everything to production, include changes to our sometimes hairy SQL Server databases. And that requires us to have a completely automated, hands-off, unattended process that executes the same way in multiple pre-production environments so that we have confidence when it's time to go to production. All right, and the last must-have is the ability to observe what the software is doing without having to exercise production level administrative access in order to do that, or have to query the production database to try to figure out what just happened. We should be recording events and metrics and exporting that data to a location or a system that is outside of the environment so that we don't have to be on the environment in order to gain access to that data. We're essentially building up a data warehouse for that data. And here's how that might look when going from the logical structure of an application to an environment. Now in Azure, application insights, you're going to want one of those for each environment. I know Stackify and some other tools, sometimes they have environment segments built into the products. Just depends on what product you happen to be using. Now I want to talk about telemetry because there's 3 types at a minimum that you need to be recording. One is the same logs that you used to, and probably for many decades, people are used to just extemporaneous logs of narrations or journaling of what the software is doing. But the other 2 are really modern concepts that can be coupled with the Kimball method of data warehouse design to enable essentially a data warehouse full of activity data that we can use the same data analysis tools that other people in the business use, like Power BI, Excel Power View, Tableau, all of the data science tools to create trends and charts and gain answers to questions from the data if we build up that set of data over time. And so events are essentially recording every time the software does something. Every function of the software needs to be a named event. Every action that a user could take, every button that a user could press, every screen that a user could load, every transaction that a user could invoke, every time a scheduled job is triggered by its schedule and commences and finishes, and every transaction it does, that is an event. The software is doing something and it needs to have a name. To go along with the events, we need to define metrics. So events are strings, they are names, they are unique names. Metrics are numbers, and whether it's performance timings or counts or any number that goes along with the event, those need to be streamed to a off environment database of some type, whether it's application insights or Stackify or anything else. And with that, we'll be able to essentially query that body of data, grouping by events, filtering by events, and then performing aggregate functions on the metrics, sum, min, max, count, all of those things. And we'll be able to use data analytics techniques in order to gain information over time about what things happen, not just the current state of things, but what things have changed over time, and start creating a lot of interesting line graphs because we've recorded that. Okay. All right. So to review the 7 must-haves, we talked about the pre-code design process, the source control structure, the private build, the team's continuous integration build process, testing and verification, including pull request and full system testing, what to do about or how to do production releases, and then telemetry observation. And those really are the 7 must-haves. Now that is a high level walkthrough. I realize that, and there's so much detail that goes into it, but those are the 7 must-haves of any environment. And we actually have a 30-point DevOps environment inspection that breaks out these 7 different areas into a lot more detail. And we've seen this our framework, our .NET DevOps framework, make a huge impact for our clients. And we have some client stories available on our website. Pop Hutchison, for example, when equipped with a complete professional work environment and a strategically determined process, we saw their team really become world-class. And you hear of teams who move fast at Google and Netflix, Microsoft, but any of your teams can be just as effective when equipped properly. And it could be tools, could be processes, or it could be skills, whether you send some of your developers to our .NET DevOps Bootcamp next week. So remember, send me an email so I can send you a free copy of my book, of the select chapters of my book. And as you read that, use the included Azure DevOps Services project template. It's called Onion DevOps. It's a project template called Onion DevOps. And literally get up and running within a day. And also be sure to subscribe to my podcast, the Azure DevOps Podcast. And And, next week, stay tuned in as we continue our webinar series. We are doing those. We took a quick break for Christmas, but we're back up and running. And so we'll be doing weekly webinars, and go out there and design your pipeline and get automated. I believe that I have answered the questions that popped up in line, but if there's any that come out here, then make sure those get answered. But here's my contact information, direct phone number, email, Twitter. Please reach out with any questions about this material or any project challenges you might be having. And also, we have an awesome video about how we helped jumpstart a really important project for a client at bit.ly/project jumpstart story. Our goal is for you to be self-sufficient. You're doing a project that's really important. You're not interested in outsourcing your projects. You're not interested in perhaps using a dev shop, but you really need the project to go well. That's what we're here for. We are here to make your team deliver world-class results, to move fast, to deliver quality, and to run that system with confidence. And you want to elevate the self-sufficient capabilities of your team. And so we love empowering software development teams, and that's what we're here for, and that's why we do these webinars. So I think we got all the questions in. Thank you so much for your attentiveness today. We recognize that your time is really valuable, and so I hope you have a great day and a great start to 2020.